With the color map method of representing an image, every element in the M by N image matrix mate is an integer in the range from 1 to p, and that integer refers to a particular row number in the color map matrix. The color map matrix stores the red, green, and blue components of the different colors in 3 separate columns. So the size of the color map matrix is p by 3, where p is the number of colors, or in other words, the number of rows. If the type of elements in the color map matrix is double, the numbers range from 0, which represents the absence of that color, to 1, which is the brightest possible hue of that color. Once you have created your image matrix, the image function displays that image matrix using whatever the current color map is. The color map function can be used in 2 ways. If no arguments are passed to it, then it returns the current color map, so it will show you the actual values in the 3 columns of the color map. And if instead you pass a p by 3 matrix to it, the color map function sets that matrix to be the current color map. So those colors are the colors that would be used when you display an image matrix. So here's a schematic of what the image and the color map matrices look like. So the image matrix is M by N, so we have M rows and N columns, so that's our image matrix. So if the image matrix actually is this small, then you're going to see very crude blocks of colors when you actually display the image. So typically an image, a photograph for example, would be quite large. Every element in the image matrix is an integer from 1 to p. So every element in the image matrix is an index into this color map matrix. So it refers to a particular row in the color map matrix. So if this value in the image matrix is x, where x is an integer, that means that it's referring to this particular color in the color map matrix. So that means when you display the image, the block here for x, however large that pixel is, that will be this color, whatever this color is. So again, the 3 columns here represent the red, the green, and the blue components of that particular color. So if this element right here is 3, that means when the image matrix is displayed, this third row, this third color in the color map matrix is going to be the color of this particular pixel. So again, in the image matrix, every element is an integer, which is an index into this color map. It says which particular row, which means which particular color is going to be displayed in that location in the image matrix. MATLAB has several built-in color maps. The one called JET is the default. There are many other color maps. For example, there's one called Autumn, which has all of the fall foliage colors, so in other words, shades of reds and oranges and yellows. It has a built-in color map called Pink, which has shades of pink and also some white and gray colors in it. All of these have 64 colors, so the size of these color map matrices is 64 by 3. So 64 rows, 64 colors by 3. So for example, if we make sure that JET is the color map by saying color map parentheses JET, so that would be the default, but if we've changed it, then we're changing it back here to be JET. And then if we use the color map function by just calling it with no arguments, it will display the 64 colors in the JET color map. So we can see, for example, here, the first 4 colors are actually shades of blue. So remember, it's red, green, blue components. So the zeros say we have no red, we have no green, but we have varying shades of blue. So those are the first few colors in the JET color map. Since there are 64 colors, if you looked at all 64 rows in the JET color map matrix, you would see what the different colors are. We can also create our own color maps. So we can create a p by 3 matrix where p is however many colors we want to have. So on the left here, I'm just showing some different colors that you could have. 100 is full red, 010 is the brightest possible green, 001 is blue, and then combinations, 110 is actually yellow, The absence of any color whatsoever, so 0, 0, 0, that is black. And the combination of the brightest possible colors for red, green, and blue, in other words, 1, 1, 1, that actually gives you white. So those are just some examples of colors that you could have. So what I've done on the right is I've created my own color map matrix called My Colors. So the first color is red, the second color is green, the third color is blue, the fourth is yellow, the fifth is black, and the sixth is white. So it's a 6x3 matrix. So I have 6 colors altogether. If I then pass that matrix to the color map function, then that is my current color map. So right now I only have 6 colors at my disposal in the current color map. So then what I did was I created an image matrix, very crude of course. It's just a 15 by 15 matrix in which each element is a random integer in the range from 1 to 6. So when we display this matrix, each element is going to randomly show one of the 6 colors from my color map. Since again I only had 6 colors in the color map, I made the values in my image matrix integers from 1 to 6. So each one refers to a particular row in the color map matrix, so in other words to a particular color. So you see the resulting image matrix that we get. Again, very crude, we're just seeing blocks of colors. One thing you can do is you can display different shades of a color. So the numbers in the color map don't have to be integers, as we saw with the default color map jet. They can be real numbers representing different shades of a color. It can be real numbers in the range from 0 to 1. So here's another color map matrix that I've created. In this case, it only has 4 colors. It's 4 by 3. The first color is black. And then the next 3 colors are different shades of red. So I have 0 for the green component, 0 for the blue component in all cases. But for the first one I have 0, and then 0.3, and then 0.7, and then 1. So we're showing different shades of red. If I pass that to the color map function, then that becomes the current color map. And then I created a vector that has the integers 1, 2, 3, 4. So when we display that as the image, we're seeing the 4 colors from our color map. First black, and then it's kind of a dark brown, and then a dark red, and then the brightest possible red is the 4th color. Question 2. Write code that will create a color map consisting of 100 shades of green from no green, meaning actually black, to full green. So 100 different shades of green, and then display these shades of green. Color maps can be used for other things besides images. So for example, for some of the plot functions. So here I've used the sphere function to return the x, y, and z coordinates that I need for a sphere. I set the color map to the built-in color map called pink, and then pass the x, y, and z values, matrices, to the surf function in order to see a surface plot. Put the title on that of pink sphere, and I put a color bar on it, which got cut off a little bit to the right, but you can see that it's showing the different colors in the pink color map. So again, you don't have to use color maps just for images, you can use them for the plot functions as well.